Hi students, this video is on current electricity part 4. Here we will discuss the important point combination of resistors. Resistors are available in standard values. So to get the desired value of resistance in the circuit, resistors can be combined or grouped. Resistor can be combined in two ways, namely the series combination of resistors and parallel combination of resistors. Now let us discuss these two, series combination as well as parallel combination, one by one. The first one, series combination of resistors. A number of resistors are said to be in series if they are connected end to end such that the current flowing through each resistor is same and the potential difference across the combination is equal to the sum of potential difference across each resistor, that is V is equal to V1 plus V2 plus V3 and so on. That means in case of series the same current flows through each resistance, whereas the potential difference across each resistance is different as per the Ohm's law. Okay, now let us derive the expression for equivalent resistance of two resistors when they are connected in series. Now, consider the two resistors R1 and R2 which are connected in series, and the same current I flows through each resistor. Then as per the Ohm's law, the potential difference across each resistor is different, that is V1 and V2 respectively, as shown in the diagram. Now, according to Ohm's law, the potential difference V1 across the resistance R1 is V1 is equal to IR1, and the potential difference V2 across the resistor R2 is V2 is equal to IR2. Let Rs is the equivalent resistance of the combination, then V is equal to I into Rs. Then here R1 and R2 in series, therefore in series the total potential difference across the circuit is equal to V is equal to V1 plus V2. Therefore from equations 1, 2 and 3 we can write uh, IRS is equal to IR1 plus IR2. So on both sides, by taking I as a common, I get cancelled here. Therefore RS is equal to R1 plus R2. That means when the resistors are connected in series, the total resistance of the circuit is equal to the sum of the total individual resistances which are connected in series. This is known as the uh, law of series combination of resistors. So suppose if you have connected three resistors in series, then Rs is equal to R1 plus R2 plus R3, and for n resistors in series, Rs is equal to R1 plus R2 plus R3 plus and so on plus Rn. In series combination, the effective resistance is always greater than the greatest resistance connected. For example, if you have connected 2 ohm resistor and 3 ohm resistance, so the effective is what? 3 plus 2, 5 ohm. So it is greater than the greatest resistor connected in this way. Okay, now let us discuss the second case, parallel combination of resistors. A number of resistors are said to be in parallel if they are connected between the two common terminals, such that the potential difference across each resistor is same and it is equal to the applied potential difference between the 2 points, and the different amounts of current flows through each resistor, and the net current through the combination is equal to the sum of current through the individual resistors, that is I is equal to I1 plus I2 plus I3 and so on. Okay, now let us derive the expression for the equivalent resistance of two resistors when they are connected in parallel. Now let us consider the two resistors R1 and R2 which are connected in parallel. That means they are connected between the two common terminals, and from the Ohm's law, the current through R1, the resistor R1 is equal to what? I1 is equal to V divided by R1, where V is the applied potential difference, and the current through the R2 is equal to I2 is equal to V divided by R2. Call this as equation 1. Suppose if Rp is the equivalent resistance of the parallel combination, then I is equal to V divided by Rp. So as R1 and R2 in parallel, so in parallel combination I is equal to I1 plus I2. So therefore the from equation 1, 2 and 3 we can write V divided by Rp is equal to V divided by R1 plus V divided by R2. So on both sides the V get cancelled here by taking the common, and therefore we can write 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2. This is for parallel combination. So therefore, when the resistors are connected in parallel, the reciprocal of effective resistance of parallel combination of resistors is equal to the sum of the reciprocal of the individual resistances. This is known as the law of parallel combination of resistors. So this can be extended to three resistors also. Suppose if three resistors are connected in parallel, then the effective resistance 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. For n number of resistors in parallel, 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 and so on, plus 1 divided by Rn. In parallel combination, the effective resistance is always smaller than the smallest resistance connected.